Okay, we're looking at the question from yesterday's handout on calculating the area of a right triangle with the given coordinates. All right, so when you're solving problems, whether it's this problem or any other problem, you really need to get good at a few things. First of all is reading the question carefully and looking at the important information. So we are being asked to calculate. So I know I'm going to need to find a calculation of some sort, and it's asking me to calculate the area of right triangle PQR. So area of a triangle, I'm just going to jot this down here on the side. I know that the area of a triangle is equal to base times height divided by 2. So I'm linking information that's given in the question with something I already know, making connections here. Now the second thing it's telling me is that this is a right angle triangle. Now when I'm calculating area of a triangle, I know that the base and the height have to meet at a 90-degree angle. And if this is a right angle triangle, then I could use the one side as my base and the second side that forms that right angle as my height. Okay, so that is going to make this question a bit easier. If it was a question that gave you a triangle that wasn't necessarily a right angle triangle, you would actually have to figure out what that length of the altitude would be. Okay, and that's a whole different kind of question. It becomes a lot more tricky, but you can problem solve through that. You have all the tools that you could actually get that. All right, so I know I have to calculate the area. I've got the formula. I know it's a right triangle, so all I need to really do is figure out the length of the two sides of my triangle. So I'm thinking length formula is probably going to come into play with this. Also, I need to figure out what two sides meet at 90 degrees to know which two sides I should actually find the length of. So to help me do that, I'm going to sketch. I'm going to actually try and draw a graph or sketch a graph to represent these 3 points. So if you want to take a minute and do that, and then you can continue the video, you can put it on pause for now. Sketch it out, see if your sketch matches mine, and then we can talk about next steps. If you want to go ahead and solve as much as you can, please feel free to do that. You have the choice, the luxury of putting me on pause, but please don't just put me on mute the whole time. Try and actually listen to the explanation because hopefully it'll make more sense once you do. Okay, if you sketch this, you should be at -2, -2. So P should be down here at -2, -2. Q is 4, 0, so +4 on the X and 0 on the Y. That puts you right on the X-axis. So it's what we call an x-intercept. R is at 2 and then 6. 1, 2, 3, 4, 5, 6. So just a sketch here. Here is R way up here. All right, so now I'm going to join these together and get an idea of what this triangle looks like based on my sketch. All right, and hopefully yours looks a little better than mine. Mine's pretty wonky. All right, now based on what I have here, and what my diagram looks like, I think, I'm hypothesizing here, I'm making a conjecture based on my diagram, I think that my right angle is where PQ meets RQ. So right in here, I think that's my right angle, but I want to make sure. I'm going to show that PQ meets RQ at a 90-degree angle. Okay, and to show things meet at a 90-degree angle, we need to show that their slopes are negative reciprocals of each other, that they're perpendicular. So again, you can put me on pause, try it out. Otherwise, keep listening, and I'll go through the solution. Okay, I'm going to find the slope of PQ, and I know my slope formula is that y2 minus y1 divided by x2 minus x1. So that's our grade 9 formula that we're using lots here. It just doesn't go away, even though my calculus kids use it. All right, if I look at PQ, my y2 could be 0, my x2 could be -2. So 0 take away -2, and then divided by 4 take away -2. Okay, so 0 take away -2 would be +2, 4 take away -2 would be a 6, and that's going to give me 1/3. So in lowest terms, that does make sense. It goes up to the right, it's fairly flat. I think we're good with that. Okay, now I'm going to find my slope of RQ. So R to Q. So again, y2 minus y1. I don't like this, how this is coming out on here so well. Divided by x2 minus x1. And I'm looking at, I'm just going to do these in different colors here. I want the 6 take away the 0 So 6 take away 0 divided by, and then I would have 2 take away 4. 2 take away 4. So that's going to give me 6 divided by -2, which is equal to -3. All right, so clearly these are negative reciprocals of each other, so that tells me that side PQ meets side RQ, or is perpendicular to side RQ. It meets it at a 90-degree angle, or it's perpendicular. Okay, so that means then I could use PQ as my base side, and I could use my RQ as the height of the triangle. All right, so now what I would need is my length of PQ and the length of RQ, and then I can use that in my formula that I have there. So if you, again, want to put the video on pause, try it out, see what you know, that'd be great. If not, continue listening. All right, our distance formula, d squared is equal to rise squared, or run squared, plus rise squared. So this is one way we wrote that formula. It's also equal to, run is really x2 minus x1. So I'm just writing variations of the formula down. You don't have to have all these variations down. I just want to remind you of how it comes about. So that means my distance formula is the square root then of that. That's where that formula came from. x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to find the distance between P and Q. It's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So my distance formula is there. Now I've already done some work here. I know that on the top here, there's my y2 minus y1, which matches up with this, which then matches up with the number 2. So my y2 minus y1 ended up equaling a 2, so that's going to be my 2 squared, my y2 minus y1, and I have my x2 minus x1 here on the bottom. So that's the bottom number here, which gives me this bottom number here. That's the 6. If you want to recalculate, by all means go ahead and recalculate, but otherwise, like, use what you've already done if you are satisfied that what you've done is correct. Okay, so that gives me a distance of the square root of 40. I'm not going to take that to a decimal. I'm just going to leave it like that, and I'll use my calculations in the rest. Try the distance between R and Q, and I'll put up my solution for that. Okay, so I got a length for RQ to also be the square root of 40, and I've just pulled, again, my y2 and y1, x2 minus x1 off of the slope calculation, and now we're ready to calculate the area. So our area is our base, which I said was going to be PQ, which is 40, and really it doesn't matter whether you use RQ as the base or PQ, the other one just has to be the height or the altitude. All right, so that gives me root 40 times root 40, which will give me 40 divided by 2, which is 20. So therefore, the area of the triangle is 20 square units. Or 20 units squared. Okay, so again, when you're doing these questions, make sure you read the question carefully, link or write down any information formulas that you think you're going to need to use for that question. Try sketching it to help you organize information, and then work yourself through that problem. Make sure you're putting in a good effort with all the questions that you're trying, and help each other out.